Okay, so 1.2 is about a thing called functions. So a function is basically just like an equation or a formula. It's going to do some math stuff. You put numbers in, you get numbers out. So if you were eavesdropping at all on trig a minute ago, we talked about x squared would be an example of a function. We're usually set up where x's go in and y's come out. The x has always been called the independent variable, and it's also been called the domain. We haven't used that word a lot together in our classes in the past, but that's a word for today. The domain is just a reference to the x's that are able to go in. The y's are the dependent variable because what comes out depends on what you put in, and the y's you can get out are called the range. For example, 2 is in the domain of this function because I can plug 2 into that. And if I plug in 2 to x squared, I'd get out 4. 4 is in the range. Is 9 in the range? Can I get 9 out?
Yeah, 3.
Yeah. If 3, we're in the domain. Are there any numbers where we plug it in and get out the same number?
Yeah, it could be
1.
That's
Okay,
right.
so 1's part of the range. 1's part of the domain. Domain is anything you can put in. Range is anything you can get out. You could get 6 out. It makes you grumpy to think about it, maybe, but how can 6 come out of that? What would you have to put in? What number could you put in to get 6 out? Square root of 6. If you put in the square root of 6 and squared it, you'd come out with a 6. Could you, well, let's try this. Which way do I want to go? Is there any number that you can't put in? Or could you square literally any number?
Square.
What'd you say?
I think you can square.
I agree. You can square any number. So for this function, the domain consists of basically every number in the math universe. There's no number that you can't square. So a way we can write that with fancy math symbols
Oh.
is that. This symbol is a symbol for
Infinite.
infinity. So this means at the high end, you can put in any numbers as high as you want to go all the way to infinity. And this means at the low end of the number line, you could put in any number you want as low as,
0, negative, anything.
yeah, negative as far as you want to go, negative infinity. You know, if my number line ended, I'd reach infinity. If the number line ended this way, I'd be at negative infinity. But this is a fancy way to basically describe with math symbols. You can plug in literally any number from negative as far as you could go to positive as far as you could go. For the range, getting things out of squaring, is there anything special about the results you get when you square? Positives only. Sort of, but we discriminated against somebody when we just did that. When we say positives only, who might we have discriminated against? 0. 0 is not positive, 0 is not negative, 0 is in a group of its own. Can you square and get 0 out? Yes, if you put in 0. But you can't get negatives. So if I want to write this with our fancy math symbols, this is called interval notation. The lowest number I can get out, we just decided was 0. Is there a limit to how high we could go? Plug in numbers, we get out answers. Is that limited or unlimited? Unlimited. So what's our symbol for that?
We're only getting that.
With an infinity now. I'm always going to use parentheses at the infinity ends, but with numbers, I'm sometimes going to use this, and I'm sometimes going to use that. It's kind of like the difference between, sometimes in Algebra 1, we did this symbol versus this symbol, or this kind of a line in Algebra 2 instead of that kind of a line. What's the difference on those punctuation marks? Like, why did we sometimes do this versus this, or that versus that? Do you remember what the difference should be? Take a step this way. Do you remember filling in or not filling in?
Not.
I do not.
It's not because it's equal to.
But I fill it in. And in both cases, since it's graders, so what does this mean that this means? Why did?
Equals.
Yeah, because it equals. This is meaning that 3 is an option. This is telling you that 3 is
Not in it.
not an option. So these are called inclusive symbols because they include that number as a good option. These are exclusive punctuation marks because they exclude. We do not want that number as an option. Here we have to be more than 3. Just being exactly 3 is not enough. So for this, was 0 an option or was 0 an outlaw? That was an option. So I want to use the parentheses or the bracket?
The bracket.
The bracket. Here's a way we can use our calculator to check that. Again, the domain has to do with x's. The range has to do with y's. If we graph this, you could punch in y equals x squared. Hit graph. If it looks ridiculous, it might be because it's set up for something that you graphed in trig last year with trig settings. You could do zoom and standard to make it be normal settings again. And you might already remember where this is going. It's going to be a U shape. Anybody not able to acquire a U shape?
I have half of you.
Okay, do zoom standard. Got a full U? Anybody not have a full U? So here's how I could interpret this graph and do the domain and range, just approaching it a different way. Where's that headed? Is it ever going to stop, or is this going to get wider forever?
Not going to stop.
It's not going to stop. That's going to get wider forever. On this end,
Same thing.
it's the same thing. It's coming from forever, and it's going to go until forever. That's why we did this. Its width is boundless in both directions. That's how the x-axis goes. The y-axis goes the other way. So in the y-axis, do we have any empty space in terms of its existence vertically? Yeah, like down here, that's a wasteland. There's nothing down here. The lowest this goes is to touch the origin. So that's where the 0 could come in. And we touched it. So since we did touch it, that's what the bracket is about. But then how tall is that going to go? Endlessly. That's where that came in. So if you want to look at a graph instead of thinking about like the math steps, check the x-axis wideness and you might be able to generate those numbers, or the y-axis tallness to do the same. Let's think about this one. I'm doing 1 divided by stuff. Can you always do 1 divided by stuff? And I'm not worried about evenly. Decimals, fractions, remainders, that's all fine. Is 1 divided by numbers ever an illegal game to play?
Zero.
You can't divide by 0. Can you divide by anything else? Yes. Okay, so this, the rule for the domain, you'd have to be able to think about. 1 divided by stuff, is there anything that's bad news? 0 itself is bad news. So it can't be a thing like this bracket. If 0 is bad news, we're going to instead switch up to the parentheses. But what we're going to get is like 2 different groups. Like all of these numbers would be good. And then we'd have to take a break at 0. But then resume because all of those numbers are also good. There's like 2 different groupings that are winners. So here's how we could do that. We could come from negative infinity always the parentheses, never a bracket for any infinity choice, to 0, take a break, start again at 0, and go as high as infinity. And we're going to put right here the U symbol from geometry for union, meaning it could be one or the other, they're both wins. Range, if you're doing 1 divided by stuff. Another way I guess you could imagine this is that you're flipping. 1 over something is also flipping it. If you're doing 1 divided by stuff, is there anything that can't happen? Like if you do 1 divided by a really big number, you'll get something really small. If you do 1 divided by something really small, you'll get something big. Is there anything you can't do?
Roots?
No, you could do. You're discriminating against the same number again.
0.
0. You can't do 1 divided by anything and get exactly 0. No matter how much you divided by, there would always be something there. Like if you had 1 cookie and tried to share it with the entire world, you'd still get like a cookie molecule. Like you could never do 1 divided by something and get 0. So this answer is literally every number except for 0. How can we write that?
0
No.
Parentheses. 0, comma, infinity.
Okay, that would get us all the positives. We could get negatives
And
too.
negatives.
Okay?
Parentheses, 0, comma, negative, infinity.
The quickest way to describe that is the
Done.
same answer we just did. So it's going to be, sometimes they're the same.
Wrong date. This is wrong way.
This symbol had a rule you might have forgotten. Does anybody remember this symbol having a rule?
Can't be on the one of a row.
That's true. There's another thing about that symbol too. You can't square root negatives. You also, if this symbol is used, are not allowed to churn out negatives. Let's not discriminate though and consider 0, whether that'll work or not. Can you square root 0?
Yeah,
Yeah, and you'll get out
0.
0. So this, you can put in 0, you can put in positives. How would that look?
You try to have it against the negatives.
Negatives are bad news. So how?
Even negative infinity with like a bracket.
No, because if you do negative infinity, you're living in the negatives, and negatives are bad news.
And just about the one
Infinity
part.
is 0.
Okay, but we'll always want to go from littlest to biggest.
0, infinity.
0 to infinity. 0 is the lowest number you can do a root of. Infinity is the highest end. This is always
Parentheses.
parentheses, and this is a choice. Could 0 itself be u?
Yeah.
Yeah, so
Bracket.
the range is the same. Still a root, but when I throw subtracting in, you have to be a little bit cautious. Okay? Again, you're not allowed to do square roots of
Negative.
negatives. So, give me some numbers that you could put in here.
1,
1.
2, 3, and 4.
Could you put in 5?
No, okay.
Could you put in negatives?
Yeah.
Yeah,
Minus,
because
minus, plus.
minus minus makes plus. So we could put in here, any of those would be fine. 1, 2, 3, 4. 4 itself would be fine. Is anything bigger than 4 going to possibly? No. Because if we do 4 minus that stuff, we're getting negatives and rooting them, and that's bad news. So how low could you go?
Negative.
Negative infinity. What was our top mark? 4.
Parentheses.
Yeah, parentheses.
Parentheses or bracket?
No, bracket.
Bracket, because 4 itself
Can work.
can work.
That's parentheses.
That's always parentheses.
It's like our homework. This is like what we're
Some
doing.
of it. There's other stuff that's easier than this.
I'm gonna get home and
Like
show you
weird.
class.
Yeah, it is weird.
Not.
It is, I agree. Range on this, Anytime this symbol is used, you cannot get any negatives. So the lowest possible number to consider if negatives are out is 0. Can we get 0 out of this?
Yeah,
Yeah, if you put in
4.
4. Put in 4, you'll get out 0, so that is a
Bracket.
bracket. Can you get big numbers?
No.
What's the four?
Yes.
Yeah. All the way to,
4. Yeah, it's 4, right?
if I go 4 minus negative a million, 4 minus negative a billion, 4 minus negative, I can go for as high as I want. For this one, what's some stuff you could put in?
Just put in 1.
1 would be okay. 1 would get you out
0.
0.
Negative
You could put in negative 1. Negative 1 would get you out
one.
a 0. You could put in
A lot of it. You do all the negatives.
You're always discriminating against this number.
Yeah.
You could put in 0, and you'd get out 1. Are there any other numbers that would work? Not in the whole number family. You could do some decimals and fractions and stuff like that, I guess. If you did 1 minus stuff that's like halves and thirds and whatever, those would work. What's the lowest number then that you could use? Negative 1. Were we allowed to use it?
Yeah.
Yes. What was the highest number we came up with?
One.
1. Were you allowed to use it?
Yeah.
Could you get out negatives?
No.
No. Anytime that symbol is used, negatives are out. Could we get out 0?
Yes.
Yes. Include?
Yeah.
Yes. Could you get out anything more than 1?
No.
No. Because if you're doing 1 minus stuff, that can't be any bigger than 1. And if you're going to root it, it can't make it bigger still. It's the maximum number you could reach would be 1. Let's use our calculator again, and we'll look at that a different way. We didn't have time to look at those all on calculator use. Okay, but hit the y equals button. And punch in the root button, which is yellow, and then the square button. 1 minus the x, and the parentheses, wait now, do the squared, and then end the parentheses, and hit graph. And it's a pretty small graph, but it looks like that. It's a half circle. Anybody not get a half circle? Standard. Anybody else not a half circle? So then we go back to this bit of advice back at the beginning. If we're looking for the domain, look at the wideness of it. Where did it start from? Negative 1. How far did it go? 1. That's our domain. For the range, look at the tallness of it. In the tallness world, where did it come from? 0. How high did it go? 1. Or no? Yeah. So we're 0 to 1.
Why can't you use negatives and do minus plus or nothing?
No, because the power overrides that.
Oh,
Order of operations, the power would happen first. So if you tried to put in negative 3, it squares it to a positive 9, and then subtracting is done. So we did some graphing on the TI, the calculator, so I had that there to remind me of that. There are some graphs on page 15 that are like not bad graphs to know that they exist on page 15. I'm not going to run through what all the graphs look like. I'm not asking you to memorize a bunch of graphs now, but they're there, and it's not such a bad thing to know as a resource to you. The next little topic, there's a thing called even functions and odd functions, and this is going to be an easier explanation. Even function, the simplest way to explain this is that we have symmetry to the y-axis. Symmetry to the y-axis means it's the same on both sides. So like this picture we just did, is it the same on both sides of the y-axis?
Yeah.
Yeah, so this is even. When we did this, Emily had a little left. When we did this, is it the same on both sides? Yeah, so that is an even function. If we didn't have a graph, another way you could test that is, think about what would happen if you put in a positive number versus putting in a negative number. Would the results match? So something, taking a stroll back to the left. On this, if I put in 3 and I put in negative 3, would the results match?
Yeah.
Yes, another reason why it's even. Something like this, if I put in 3 versus putting in negative 3, would those match? No, so that is not even. Put in 9, put in negative 9. Match?
No.
No, not even. Put in a negative, put in a positive, match?
Yeah.
Yes, we already did that. That was even. Here, put in negative 6, put in positive 6. Match? No, so not even. Question not even. Odd, we could either look to the graph, and there's a thing called being symmetric to the origin. That would be something like this, that mirrors the diagonal quadrants. If I did something like this, that's symmetric to the origin if we're mirroring the diagonal quadrants. If you don't have a graph handy, think about put in a positive versus put in a negative. Are they an almost match, but the sign is screwed? So if we go back here, put in 5, put in negative 5. Is that an almost match? Yeah, the only difference is the sign, so that is an odd. Put in 5, put in negative 5, does that almost match? No, because putting in negative 5,
You can't do
you
it.
can't even do it. So this is a nothing. Put in 5, put in negative 5, are those even close? No, so that is a nothing out of that question.
Thanks, Ashton.
Save the easiest for last. The homework goes in a nice order in that sense. In case you were thinking, boy, did this start off and get worse, the answer is no. It'll get better. There's a thing called composite functions, where these are artificially easy. These are not homework problems for today. This is an Algebra 2 flashback. But these are what the homework will encounter today. They'll give you one formula, call it F, whatever letter they want to pick. If they talk about F, they want you to square stuff. If they talk about G or some other letter they might use, they want you to add 1 on. So if I ask you to find F of 3, I just want you to take the 3 and do what F is telling you to do, which is to square the thing. And you come out with 9. If I want to do G of 4, I just take 4 and I do what G says, which is to add 1, and I make it 5. That's not calculus yet, that's just an Algebra 2 thing we used to do. Anybody mad at that? Composite functions means they're going to do 2 of them. When you have nested parentheses, meaning parentheses inside parentheses, where do you start? Inner. So we want to start with 3, do what G says.
So that's 4.
So we're up to 4. Hold the 4 now. 3's dead, 4's alive. 4 goes to F. 16. This, you'd start with 4 and go to
16.
the F makes it squared is 16. Take the 16 on a trip to G,
Make it 7.
make it 7. Anybody with that? Recap. This we're just going to double dip. We're going to use F twice. So we take 2 and go to F.
So that's
4, and then do F's thing again. We're up to 16. This I double dipped the G. 5 to G makes 6. Go to G again, makes 7. They'll sneak in a couple where it's all variables, and it's actually, I think, even a little bit easier than the numbers were. If they want you to grab G of X, you would grab this whole thing. In your mind, we're holding all of it. And we want it to go here, where we were going to squares. So conceivably, that might be an okay answer in their mind. Also possible, they might want you to FOIL that out. So if we FOIL that out, x squared, 2x plus 1. Because it would mean that there's 2 of them side by side, the FOIL, a 1x, another 1x, if we got the 2x. This, we would go look at the f of x thing first,
X squared
and then do what G says to do after.
plus 1.
X squared plus 1. That's all we need. Homework's on 19. So 19, the syllabus will have the numbers. Let's do a brief cruise through, but we're down to like pretty close to the bell. 1 and 2 might just become a research project. If you don't know the answers to 1 and 2, just do a little bit of a research some way or another. 6 to 18, we're going to do the even ones, because if you do the odd ones where you have access to the answers, you may fool yourself into thinking you know what you're doing, when in fact you do not. So the domain range thing is going to be evens, 6 to 18. 22 to 32, we're also doing evens. Those are about like the even, odd, or neithers through that group. And then the easier group at the end will be 53, 54, where we're doing this composite function thing. So 1, 2, I did nothing like 1, 2. That's just a research project. 6 to 18 evens, domain range. 22 to 32 evens is this odd, even, neither concept, and then those last 2 are the composite. That should seem harder than yesterday because you've done very little of the domain range thing before. That's the hardest thing you'll do in chapter 1. So if you're like, does this get worse? No. Domain range is the most aggravating thing from chapter 1. It is what it is. That's it.